When several particles move towards the same electrode, how do we decide which one reacts? The particle that reacts is said to be discharged. If one particle reacts more readily than another, it is preferentially discharged. For aqueous electrolysis at O level, we use different selection rules at the cathode and at the anode. An aqueous electrolyte contains the dissolved substance together with water. At O level, we therefore consider the ions from the dissolved substance as well as H+ and OH- ions associated with water. This means that several possible particles may move towards the same electrode. However, they are not discharged equally readily. One particle is usually preferentially discharged and forms the product. Let's organize the selection rules into two branches, the cathode rule and the anode rule. At the cathode, reduction occurs. Positive ions move towards the cathode and gain electrons. To predict the product, compare the metal with hydrogen in the reactivity series. If the metal is more reactive than hydrogen, the metal ion is not normally discharged from an aqueous solution. Hydrogen forms instead. This includes metals such as potassium, sodium, calcium, magnesium, aluminium, and zinc. For example, when sodium ion Na+ competes with hydrogen ion H+, hydrogen is produced rather than sodium metal. If the metal is less reactive than hydrogen, the metal ion is preferentially discharged and the metal is deposited. For example, copper 2+ ion SO₄² gains electrons and forms copper. So the O-level cathode rule is metal above hydrogen, hydrogen gas forms. Metal below hydrogen, metal forms. At the anode, oxidation occurs. Negative ions move towards the anode and lose electrons. At O level, the main competition is usually between a halide ion and hydroxide ion. The halide ions considered are Cl-, Br-, and I-. If a concentrated halide solution is present, the halide ion is preferentially discharged and the corresponding halogen forms. Cl- forms Cl2, Br- forms Br2, and I- forms I2. For example, concentrated aqueous sodium chloride produces chlorine at the anode. If there is no concentrated chloride, bromide, or iodide solution, the hydroxide ion is discharged in the O-level model and oxygen forms. The half equation is as follows. So the simplified anode rule is concentrated halide gives halogen. Otherwise, hydroxide ion gives oxygen. Sulfate ions and nitrate ions are usually not discharged during aqueous electrolysis with inert electrodes. They normally remain in the solution. For example, during the electrolysis of aqueous copper 2 sulfate using inert electrodes, sulfate ions remain in the solution and oxygen forms at the anode. The electrode material also matters. These rules assume inert electrodes, such as graphite or platinum, unless the question states otherwise. A reactive anode may take part in the reaction and change the products. We can now summarize the selection rules. At the cathode, a metal above hydrogen gives hydrogen, while a metal below hydrogen gives the metal. At the anode, a concentrated halide gives the halogen. Otherwise, hydroxide ion is discharged and oxygen forms. Sulfate and nitrate ions usually remain in solution, and inert electrodes are assumed unless stated otherwise. To predict the products, follow 3 steps. First, identify all the possible particles present. Second, compare the competing particles using the correct rule for each electrode. Third, predict the product formed. So remember, identify, compare, then predict.